Well, it's always good to do better than average. So let's see. I'm going to move up so I have some writing room. Are we going to start from 1 here?
Yeah.
Okay. Let me go right there. How come I cannot get this thing to disappear? It's one of those annoying things they force on you. Okay, consider that function. Calculate the left endpoint Riemann sum using n equal 4. Rectangles, calculate the right, calculate the midpoint.
Okay.
Let me draw an approximation of this function. And you don't really need to do that, but when you're first learning these, it's helpful, kind of, to do it. It'd be more helpful if I could draw a little bit better. All right, that's good enough, I think. On the interval from 0 to 2. Okay.
Yep.
Where does my first rectangle go?
It would go from 0 to 0.5, and then 0.5 to 1, and then 1 to 1.5, and then.
Okay, we're going to call that 0.5. We're going to call that 1.5. Now, this rectangle, that's right there. We'll call it rectangle 1, just for reference purposes. Tell me what the height of that rectangle is.
At the left endpoint, it would be 0.
Yeah, in other words, rectangle 1's area, we'll call it, equals its width, 0.5, times f of 0, the left-hand endpoint. And I use that notation because that's really what you need to learn here, is how to measure the height of all of these rectangles. And it's always the function evaluated at its left-hand endpoint or its right-hand endpoint. So what is the second rectangle here?
It'd be 0.5 times just f of 0.5.
Huh? That's really the way I recommend you do these. In other words, don't fill in that number yet because it kind of destroys the pattern. In other words, once you set up the pattern, you can figure out what the rest of it's going to be. What's this one?
Of 2.
Nope. It's left hand.
No. Well, yeah, 1.5.
1.5. Okay. So it's easy enough to evaluate. You figured out that that was 0. So that's 0. This is 0.5 cubed, which is 0.125 times 0.5 is 0.0625, I believe. Do we need to do the arithmetic? But
No.
okay, good. Because here's what we're looking at. This can get sometimes confusing, especially when that left one is 0. Okay? But that's the left-hand rectangular sum, left endpoint. I'll let you do the arithmetic and figure it all out. So what changes with right hand?
It gets rid of 0 and goes to from f of 0.5 to f of 2.
Correct. So how about midpoint? We don't need to do that. You know how to do right-hand endpoint.
Yeah.
What's midpoint?
It would be 0.25 to 1.75.
Yeah.
So 0.75 and then 1.25 and then 1.75.
So 0.75 there, 1.25 there. Okay. And like I said, understand that as opposed to figuring out what y is and then multiplying it by 0.5. This is the key part here, is that these values are represented by f of wherever you are on the left-hand side of that rectangle. All right, can we go to number 2?
Yep. So
First of all, what's one thing we can do here?
can you pull the 3 out from up from the front?
And the only reason I mention it, it's not really necessary to do, but you can always pull constants out. Okay?
Yeah.
What else do we know? What do we know about those two statements right there?
Oh, the difference between the bottoms is -2 to 1. So don't you subtract them?
Yes. In other words, what is it from -2 to 1? What is this? What is from -2 to 1 just f of x? Let's lay out the formula. Okay? Here's what we got. We got from -2 to 7. Well, that's going to be the same as from -2 to 1 plus from 1 to 7. Correct?
Yeah.
In other words, this is really where we should start. Is how are we going to split these things up? And then you don't ever have any question about whether it's subtraction or addition. Okay? So that is going to be what?
That's going to be 3 plus a -5. Or that's going to be 3.
Well, let's do this algebra.
Oh, wait.
Never forget to do the algebra. Okay, here's what we got. In other words, it's easier to forget when you add and when you subtract, but not if you do it algebraically, it's not. Okay, so we're solving for that. So it's got to be that minus this.
Yeah.
This one is -5. Subtracting this one here, which is 3, that is -8.
Okay.
Okay? And that's what we're going to do on all of these, is we're just going to do the algebra. Okay? So, excuse me, times 3 minus 24 is the answer on A. Do you have your answer sheet in front of you? I don't know that I want it to be in front of you, but it's probably good if we check these.
I can pull it up real quick.
Well, you don't need to. I've got it on here, I believe, don't I?
I think so.
Yeah, let's just go look. It should 2a should be minus 24. It is. Okay. So again, on all of these, what can I do here on B?
Can you just take the number from A and plug it in for
No?
f of,
No.
or
Here's
negative?
a key thing with integrals. The sum of the integral of the sum is the same as the sum of the integral. That's a huge principle in calculus. It really is. When you get up into higher calculus, that's going to be used a lot because there's a lot of things that are multiplied together that if you could separate them into sums and differences, you'd be able to do them. Okay? So the first thing I can do here is say that this thing is this. Minus the integral take that 4 out where we're at it. And then we have the answers for each of these, do we not? What is that?
That is 9.
Times 4 is
9.
36. And what is this one? That's the one we calculated.
So that's 8. So 64.
Be careful.
Negative 64.
Oh, you're right. That was 8. It was 3 times that. It was negative 8, I believe.
Yeah.
Okay, so it's minus an 8 times a negative 8. So it's 36 plus 16, 52. Just check that, make sure we haven't made any math errors. Ooh, wrong. I don't think I multiplied them correctly. Okay, so this one is 9 times 4. So that's 36. What,
8 times 8 is 64.
okay, well, what was I thinking? And it's minus a minus, so 100 is the answer.
Yeah.
Yeah, because we had 36 minus a minus 64. I was doing minus a minus 8. I was forgetting to multiply by that 8. Okay. I'll bet you can do the last one on your own.
Yeah.
Maybe. What's first step?
Split them. So it's, yeah, and then 1, then.
What's the first one?
The first one is just 1.
It's the integral of 1. The integral
0.
No, the integral of 1 dx.
Is it just x?
Uh-huh. And the way you know that is that the derivative of x is 1. So we're going to evaluate that. And then we're going to subtract a minus 5, correct?
Yes.
Evaluate that. Circle on the left.
That would just, is it just,
Have confidence.
it would just be positive 9?
You got it. See, I said have confidence because I knew you knew the answer. What bothers me is when you say, is it? So what's the rest of it? 9 what?
Plus 5 is 14.
Yeah. Might seem like a subtle thing, but I do think it kind of makes a difference. When you get to a point where you know the answer, you should talk like you know the answer. Don't introduce that doubt. If you get the wrong answer, we'll definitely figure it out. Well, let's look at the problem, and maybe that thing will be working by the time I need it. Use geometry to evaluate the definite integrals. Okay. Am I going to use geometry?
This is one of the things I really have no idea what we're doing.
Okay.
So.
Screen sketch is not working. Well, let's do this a different way. And not by clicking on that Playboy Playmate. Okay, let's see. The thing is 3x minus 6 from 1 to 6. Okay, so that's our function. 3x minus 6. What does this mean? What does that mean?
Just in the, is it just in the area of from 1 to 6?
Of that function.
Yeah.
Well, let's draw that function. How do I draw that function? It's linear, right?
Yeah.
Where's the y-intercept?
It's at 6.
Yeah, no. Y equal mx plus b. That's the slope-intercept format. It's at minus 6.
Oh, yeah, it's minus 6.
What's the slope?
3.
Okay, so I'm going to go up 6 to the right 3. So that is the straight line I'm dealing with. And what this means is the area under that curve from 1 to 6. So what area are we talking about? We're talking about that area right there. Now, when they said use geometry, we don't need calculus here. We know what the areas of triangles are.
Yeah.
Well, that's 1. We know that's 3. So the area of triangle A is what?
Is it just 6?
Uh-huh. Is it positive or negative?
Negative.
Correct. Plus the area of triangle B. Well, we need this height. The base is 2. The slope is 3. Therefore, what's the height of that triangle?
Is it the square root of 5?
No. In other words, if this point is at 3, and we have a slope of 3, then if I go up 6, I got to go over 2. That's what that base is. So this distance has to be 6.
Okay.
Okay, which makes the area of that triangle also 6, which makes the area 0.
Okay.
Now, if you look at this picture, you can see that these two triangles have to be similar. Not necessarily congruent, but similar. Okay? And if I know that that base is 2 and this base is 2, then they are congruent. And if I've already figured out the area of that was 6, then I immediately know the area of that is 6 without doing the geometry, based on symmetry only.
Okay.
Okay? And by that, I mean anytime you have a straight line and you go from one number to another number, and that x is the same as that x, then that triangle A is going to be the same as that triangle B. For exactly the same reason. They have to be similar because we got a bunch of parallel lines here. All the angles are the same. And therefore, the similarity ratio is the only thing we care about, and that's 1 to 1. Because that was 2 and that was 2. All right. Let's try the next one on there. It's actually easier to do on my page anyway. So we're going from minus 1 to 1 of 2 minus absolute value of x. So f of x is 2 minus the absolute value of x, and we're going to evaluate it from minus 1 to 1. So again, when they say use geometry, you know you're going to be dealing with straight lines. You don't need calculus to deal with straight edges. You need calculus to deal with curved edges. So let's graph that. Start with the parent function. What's the parent function?
The absolute value. So it's a v, but upside down.
Okay. And then what's the 2 do? Think in terms of translations. That's
that one?
It's up 2. In other words, that's a vertical shift. It's not a vertical stretch. If the 2 was in front, in other words, if it was multiplying, but what we really have here is minus the absolute value of x plus 2. Well, anytime you have a number that comes after the function, it's a vertical shift, up or down. Okay, so if we graph this function, I'm going to draw the v upside down, and then I'm going to shift it up. It does matter the order you go. Always remember, do your reflections first. So here's what I've got. And that is at 2. What are the slopes of those two lines?
Is it just -1?
Yes, one of them is positive 1 and the other is negative 1. In other words, it's whatever the coefficient is in front of x. This is still, you can think of it as being y equal mx plus b format. Okay, so if that slope is 1, then that number is minus 2, and that number is 2. Triangle A, what's its area? Whoops, hold on. We're going from minus 1 to 1. So we're actually looking for this area here. Well, what's an easy way to get that area? That's not a particular easy thing to get an area for. I mean, I guess it is. You could do it a number of ways. But that's what we're looking at, right?
Yeah.
Okay. This base is what? A distance of 2? This
Yeah.
height is a distance of 1. And this height is a distance of 1. See how I get all those?
Yeah.
In other words, because that slope is 1, then that point right there has to be 1. And so forth and so on. So the base of this little house I've drawn here is 2. The height is 1. Let's split it up into 2 triangles. The area of that is base times height, 2. The area of this is 2 times 1 half of that, so it's 1. So that whole area is 3. Now, another way I could have done it that maybe would have been a little easier is to take the area of that triangle and subtract the area of that triangle. And that gives me the area of this, and then just double it based on symmetry. In other words, this area that I've drawn vertical slashes through is going to be 1.5. So there's a few ways to use geometry once you get the figure drawn, but the answer is always to get that figure drawn. Okay. Let's take a quick peek and make sure that's the right answer. 3B. For A, I think we're actually moving at a higher pace through these than we were the last time. The last set of problems, your preparation for that test was those were, each problem was like concerned itself with 5 or 6 different principles of calculus. I think that's one reason we moved pretty slow through. We were only getting through 2 or 3 problems a day, but each problem had, 3 or 4 problems. We're going to get through these a lot faster. There's only 1 problem per. Okay, so solve the initial value problem. Well, best way, I gotta be able, how come this thing is not working? Can't use it right now. Okay. Darn. Huh. All right, well, I'll have to go back and use the other one. 3x to the minus 2/3. Why does that other one disappear? I don't get that. It's all this cloud computing that the problem is. I wish I had a drawing thing that was not trying to sync up to the cloud every time I opened it. It creates so much problems here. All right, so what was it again? 3x to the minus 2/3. So f prime of x equals 3x to the minus 2/3, and the initial condition, which is always used to calculate c, is f of minus 1 equals minus 5. How do we get f? How do we get f of x?
So you take the antiderivative of it.
Which is the integral.
Yeah. And then
This
you
is
plug.
Yeah, this is basically the theorem of calculus. The fundamental theorem of calculus says that if you take the integral of the derivative, you get the function. So the left side is going to give us f of x. Take that integral. Always start there. Don't start here.
So it would be 1/3.
Okay, so here's what I'm going to do. I'm going to write 3x to the 1/3, and then I got to divide by that new exponent, right? That's really the only two steps of integrating a polynomial, is you add 1 to the exponent and you divide by the new exponent. Well, dividing by 1/3 is the same as multiplying by 3, so it turns that into a 9, plus what? It's an indefinite integral.
Plus c.
Yeah, and that's important because when they give you this initial condition, it's always for the purposes of figuring out c. Okay, so how do I solve for c?
You plug -1 in for x, and then
F of -1, we know that's equal to -5. And that's also going to be equal to 9 times -1 to the 1/3 power plus c. Now what I have to do, wow, is maybe reboot my computer. That's why that thing is disappearing on me. Yeah, what can I do here? Maybe if I just close this out and reopen it, that might solve my problem. Nope. Well, now what? See if I can get that thing to open. But you can see that we have an equation that only has one unknown. In other words, I've got -5 equals 9 times -1 to the 1/3 plus c. What's -1 to the 1/3? It's the cube root of -1.
1.
Nope. Cube root of negative numbers are always negative. Cube root of -8 is -2. Cube root of +8 is +2. Cube roots are different than square roots. Square roots are always plus or minus. Cube roots are not.
So it's -1.
Yeah, so it's -5 equals -9 plus c. c equals 4. There's our equation. 9x to the 1/3 plus 4. That is our f of x. Could they do anything more annoying than, what happens if I push that? Nothing good. Could they do anything more annoying than to cover up the slide bar with that thing? Okay. B is just a harder version. Let's see, it's 2 over t cubed. Apologize for this, Mitch. My computer difficulties. I probably ought to just reboot my computer before every session. Okay, so here we have f double prime of x equals what? Hold on, I got another drawing thing here. Just I'm not 100% sure how to use it. No, that's drawing with a PDF, I think. Maybe not. Do you know if Windows 10 has a drawing app?
I don't think so.
This is supposed to be it, OneNote, but it's giving me problems, and so is my Paint. Paint would do it. Use Paint. I think. Not that familiar with Paint, but all I need is something I can draw on. Very hard to do math tutoring without.
I would just click new and just draw it that way.
Yeah, I'm somewhat familiar with 2D Paint, but not much with 3D. Let's see, I have to highlight a pencil here. Let's see if that works. I vault. That is horrible. What do I need here? I need to turn this thing into a drawing. How do I do that? Are you familiar with this? Text.
Not at all.
Not text. 2D shapes. No, I don't want that. Select, I'll bet. Select. Maybe that's all I need. Mitch, let me reboot my computer and call you back in 3 minutes with a new meeting ID number.
Okay.
And if you can, I'll go over an extra 10 minutes if you need me to.
All right.
If you're to. I'll be back to you in 3 minutes. I'll text you the new meeting ID number.
All right.